Welcome to Two Projects. In this video, we are going to explain the project Automatic Diabetic Retinopathy Diagnosis using Adaptive Fine-Tuned Convolutional Neural Network. Before diving into the execution, let me give you an overview of the project. First, we'll understand what is diabetic retinopathy. So, diabetic retinopathy, that is DR, occurs when diabetes damages the delicate blood vessels within the retina. Retina is the light sensitive tissue at the back of the eye. So these blood vessels in retina are very important for good vision. So DR comes in different stages: mild, moderate, no DR, which means there is no diabetic retinopathy present, proliferative DR, and severe DR. So these are different stages of diabetic retinopathy. Detecting DR early is really important because it can prevent vision problems or even blindness. Regular checkups and getting treatment on time can help keep the condition under control. The usual way to check for DR involves eye doctors looking at pictures of the retina, but this process takes a lot of time and sometimes mistakes can happen because it depends on what each doctor sees and interprets. Different doctors have different opinions, so the decision is always changing. That is where technology comes in. Leveraging technology such as specialized algorithms offers a more efficient and accurate approach. By automating the analysis of retinal images, we can swiftly identify indicators of DR, facilitating prompt medical intervention and improving patient outcomes. So, deep learning and machine learning are advanced technologies that can automate the diagnosis of DR. These algorithms are trained to analyze images of the retina. By examining these images, the algorithms can detect signs of DR and determine its severity with high accuracy. So, to train these algorithms, we use a large dataset containing images of diabetic retinas. These images represent different stages of DR from mild to severe. The algorithms learn to recognize patterns in these images that indicate the presence and severity of DR. So, before feeding the images into the algorithms, we perform image processing techniques to enhance their quality and make them easier for the algorithms to analyze. So, these techniques include resizing the images, adjusting their orientation, and ensuring they are in the correct format. And data augmentation techniques like rescaling, sharing, flipping, zooming, etc. are used. So they help deep learning models by creating more diverse training data through image transformations. So this variety improves the model's ability to learn and generalize, leading to better performance in diagnosing conditions like diabetic retinopathy. So we will be training the models on original images but from different angles and lighting so that they can generalize to different conditions and situations. Once the images are processed, the algorithms can analyze them to identify any abnormalities associated with DR. Based on their analysis, the algorithms can classify the severity of DR, providing valuable information for doctors to make informed decisions about patient care. And the project employs various deep learning models like ResNet 152, VGG19, DPN, and Exception to categorize diabetic retinopathy. Additionally, it utilizes ResNet for feature extraction, extracting key characteristics from the retinal images. So, these features are then analyzed using machine learning algorithms such as random forest decision tree and gradient boosting to gain deeper insights into diabetic retinopathy based on the extracted features from ResNet. Following the classification process, evaluation is crucial to assess the performance of the models. So this thorough evaluation helps validate the reliability and accuracy of the diagnostic system, ensuring its effectiveness. So we will be evaluating the performance of the models built using different performance metrics and will select the best performing model. And the project utilizes the Flask framework to create a secure platform where users can assess, access, and analyze retinal images for diabetic retinopathy. Using SQLite for user authentication ensures that only authorized users can upload images for analysis. Once uploaded, the images undergo pre processing before being analyzed by trained models to predict the severity of diabetic retinopathy. The final diagnosis and severity classification are displayed to the user through the front end interface. So, this is what happens in this project. Overall, by integrating deep learning and machine learning algorithms, the project aims to provide accessibility, efficiency, and accuracy in diagnosing diabetic retinopathy. The objectives include developing an automated system for diagnosis, classifying severity, offering a user friendly platform for image uploads, and improving early detection and management of the condition to reduce the risk of vision loss. Now we look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, back-end framework required is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So in the base paper, author has compared these models, ResNet 152, VGG19, DPN, and these hybrid models where ResNet is used for feature extraction and the features extracted are used to train the respective machine learning algorithms, random forest decision tree, and gradient boosting. So after comparing all these models, the author concluded that this hybrid model combining ResNet and gradient boosting has outperformed all other models in all the performance metrics. For improved performance, we are proposing exception in this project. We will be building all these models. We'll compare them using different performance metrics like accuracy, precision, recall, and F1 score, and we'll select the best performing model among them for diabetic retinopathy severity classification. So now we will understand about the model which we have proposed, that is exception in brief. So exception is a deep learning technique. It is known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. So this helps exception to understand images better and pick up on important details. One of its strengths is that it is really efficient at doing this, which is important when you are dealing with lots of images. Plus, it is great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other datasets before being used for a specific task, that is, transfer learning. So, this makes it super adaptable and useful for projects like detecting and classifying diabetic retinopathy from retina images. So, this is about exception model. So, after comparing all these models, we have observed that exception model has outperformed all other models in all the performance metrics. So, we have deployed exception into the Flask web application. We will be executing the project in Flask. So, before execution, first we need to open the code folder which contains the project source code files. So, this is the code folder and these are the contents I have in the code folder. So this is colored images folder in which I have retina images. We can see I have 5 different class folders here: mild, moderate, no DR, proliferative DR, and severe. So these are different classes of diabetic retinopathy based on severity levels. So I have respective images in these folders. In mild folder, I have retina images of the persons who are diagnosed with mild DR. Similarly, in moderate folder, I have retina images of the patients diagnosed with moderate DR. In no DR folder, I have retina images related to no DR. Similarly, I have respective images in other folders also. So on these images, we will be training the deep learning models. So before training the deep learning models, we will split the dataset into two subsets, train and validation sets. So after doing that, we have stored train and validation sets in the output folder. So train folder images are for training the models and validation set is for evaluating the model's performance. And in sample folder, I have images of 5 different classes again. On these images, we will make the predictions. So these are the test cases. So in static folder, I have files related to CSS, JavaScript, and Bootstrap. Templates folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the train models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. It stores information like user sign-up details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path, I'm copying it. Open Anaconda prompt. So here we can see it is locating to the C drive, but we have the code folder in the D drive. So we have to change the drive location here. For that, use the command D : and hit the enter button. So we can see the drive location has been changed. Now use the command cd followed by a space and paste the copied path of the code folder and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a logon link, click on it. So if we are new users, we have to register ourselves first. Fill in these details and click on submit button to register. And if we already have account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine. And click on submit button. So it has redirected us to the classification page. So now we have to upload any retina image here and the application will classify the severity level of diabetic retinopathy from the image. Click on choose file button from sample images folder. So these are different classes I have. We'll upload any image from the mild folder first. So these are test cases I have. I'll try uploading the first image. Select the image, click on open. The image has been loaded. Now click on upload button. This is the uploaded image, and here we can see the diagnosis, that is mild diabetic retinopathy. The application has correctly classified the severity level of DR as mild diabetic retinopathy from the image. Click on back, click on choose file. We'll try uploading this one. Select the image, click on open. The image has been loaded. Now click on upload button. This is the uploaded image, and here we can see the diagnosis, that is mild diabetic retinopathy again. So the application has correctly classified the severity level of the DR from the retina image as mild diabetic retinopathy. Click on back. Click on choose file. This time we'll try uploading image from moderate folder. So I'm uploading this one. Select the image, click on open, click on upload. This is the uploaded image, and here we can see the diagnosis, that is moderate diabetic retinopathy. Click on back, click on choose file. We'll try uploading any image from no DR. I'll upload this one. Select the image, click on open, click on upload button. This is the uploaded image, and here we can see the diagnosis, that is no diabetic retinopathy. So this person do not have diabetic retinopathy. Click on back, click on choose file. I'm uploading this one. We can see the diagnosis as no diabetic retinopathy again. So we can see the correct classifications. Click on back, click on choose file. This time I'll upload any image from proliferative DR folder. I'm selecting this image, click on open, click on upload button. This is the uploaded image, and here we can see the results, that is proliferative diabetic retinopathy. The application has correctly classified the severity level from the uploaded retina image as proliferative diabetic retinopathy. Click on back, click on choose file. I'll try with this one. This is the uploaded image of retina, and here we can see proliferative diabetic retinopathy again. So the application has correctly classified the severity level of DR as proliferative DR. Click on back, click on choose file. This time we'll upload any image from severe folder. I'll try uploading this image. This is the image I have uploaded, and here we can see the diagnosis, that is severe diabetic retinopathy. Click on back, click on choose file. I'll try with this image. This is the uploaded image, and here we can see the diagnosis, that is severe diabetic retinopathy again. So in this way, we have to upload any image from the test cases we have. Select the image, click on open. The image has been loaded. Now click on upload button. So the image has been uploaded, and we can see the diagnosis here, that is moderate diabetic retinopathy. So we can see the correct classifications here. The application has correctly classified the severity level of DR from this retina image as moderate DR. In this way, we can upload any image from the test cases and can get the classifications. Now click on the About link. So here we can view all the visualizations made. This is accuracy and loss graph of exception. This is accuracy comparison graph, a horizontal bar graph comparing accuracy scores. So in this graph on x-axis, I have accuracy scores and on y-axis, I have algorithm names. So these are all the algorithms built. So accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. Precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. And this is F1 scores comparison graph. F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. So these are the graphs plotted. Now click on logout. So by employing deep learning and machine learning, the project automates diagnosis, classifies severity, and facilitates early detection, reducing the risk of vision loss. So the project employs Flask and SQLite to create a user-friendly platform for diabetic retinopathy analysis. So the project's accessible and efficient approach enhances patient care in managing diabetic retinopathy effectively.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.